Welcome to all. Today we will look into three position synthesis of slider crank mechanism. Three position synthesis of a slider crank mechanism. In the first step, we have to draw two parallel lines x1 and x2. Here this line is x1 which is passing through the slider block, center of the slider block. Then another horizontal line which is passing through this pivot point is represented as x2, x1 and x2. First we have to draw two parallel lines x1 and x2 are drawn at a distance of E. E is equal to eccentricity, that's equal to 0.9 centimeter given in the question. Second step, on the line x2, locate any point A arbitrarily. Here on the line x2 we can locate this point A, any point on the line x2. Then from A, draw a line y1 perpendicular to x2a. Draw a line y1 perpendicular to x2a. Draw a line y1, this line y1, which is passing through A, which is perpendicular to this x2a. Then draw lines y2 and y3 perpendicular to ax2 or parallel to this y1 such that a d1 is equal to s12 by 2. This a d1 is equal to s12 by 2. Here this distance s12 is given in the question. Then s12 divided by 2 is equal to 0.9 centimeter, and a d2 is equal to s13 by 2. That's equal to 2.4 centimeter. This distance is equal to 2.4 centimeter. Then draw lines z1 and z2 passing through A such that angles y1a z1, this angle is equal to theta 12. This angle is equal to theta 12 by 2. This angle is equal to theta 12 by 2, that's equal to 20 degree. And angle y1a z2, this complete angle is equal to theta 13 by 2. That's equal to 40 degree. This angle is equal to theta 12 by 2. This angle is equal to theta 13 by 2. Then we can easily construct these lines AZ2 and AZ1. Then in the next step, we have already drawn this line y1, y2, y3, z1 and z2. Then in the sixth step, extend lines AZ1 and AZ2 to intersect lines y2 and y3 at pole points P1 and P2. Extend line AZ1, extend it up to this vertical line y2 and find out this pole position P1. Similarly, extend AZ2 up to the vertical line y3 or find out the intersecting point of AZ2 and y3, and that is the second pole position P2. We can easily locate P1 and P2, pole positions P1 and P2. Okay. Then next step, seventh step, locate C on the line x1. Locate C on the line x1. arbitrarily. This point, we can locate this point C randomly on line x1. We can select any point on the line x1. You can select any point on the line x1 as C. Then draw a line, then join P1 and P2 to point C. Join P1 and P2 to C. Join P1C and P2C. Then in the next step, draw line P1M. Draw line P1M such that the angle M1 P1C, M1 P1C, this angle is equal to theta 12 by 2. Theta 12 by 2, that's equal to 20 degree. Then draw a line P2M. Draw a line P2M such that M2 P2C, M2 P2C, this angle, this complete angle is equal to theta 13 by 2. Theta 13 by 2, that's equal to 40 degree. Given in the question, theta 13 is given in the question as 80 degree. Okay, next, the extension of line P2M2 and P1M1 intersects at point B. Extension of line P2M2 and P1M1 intersects at point B. Now join A, B and C, which is the required slider crank mechanism. Join A, B and C, that is the required slider crank mechanism. This is the 3-position synthesis of slider crank mechanism. We can discuss 3-position synthesis of 4-bar mechanism in the coming presentations or video notes. And this is the final answer. Thank you all.